Hello students, let's begin lesson 11. Lessons 11 and 12 will cover chapter 8 of our textbook, hypothesis testing. In statistics, hypothesis testing consists of two competing hypotheses. One is null hypothesis and the other is alternative hypothesis. Null means none, nothing. So that's the default. If there's no evidence one way or the other, then we go back to default. Status quo or past or ruling in the field, those kind of things are null hypothesis. Alternative hypothesis is, of course, the challenger. In criminal justice system, for example, H0 is not guilty and HA is guilty. In a sporting event, for example, null hypothesis is the ruling in the field. For example, in a football game, the ruling in the field is receiver caught the ball, it's completed pass, and of course the opposing team challenges. No, the ball hit the ground first. Those kind of things are null and alternative hypotheses. And if there is no conclusive evidence one way or the other, then we just go back to default, null hypothesis. Mathematical structure is generally like this. So we want to find out the mean, and the mean is mu0, the expected mean value, which comes from the past consideration most of the time, or somebody else's claim. And compared with that, alternative hypothesis looks like this usually. No, it's greater than that, or less than that. Not just a little bit greater or a little bit less, but significantly, statistically meaningfully greater or less. In some cases, we can consider the third case. The alternative hypothesis is they're just different. I don't know whether the real mean is greater or less. They're just different. But this one is really rare because we already did the sample study and the sample mean is either greater or less. One way or the other, we already know whether we have to take this path or that path. Why do we have to consider this? That's actually beyond me. So in classroom purpose, yeah, we can consider this, but in reality, that's not really realistic. Also, if you want to claim that mu is not equal to mu0 or just different, I don't know whether it's greater or less, it's just different because it's so unpredictable, then you have to do these kind of things to standard deviation. Standard deviation sigma, the population standard deviation, is much bigger than sigma 0, so more spread out, more unpredictable. So the third case here is, what can I say? I don't like this very much. I may write this kind of problem, just copying the textbook problem, but that's about it. In reality, we don't really consider it. Now, how do we quantify so that we do some mathematics with it? There's something called the level of significance, which is basically the threshold of conditional probability, a certain conditional probability, and we're going to denote it with Greek letter alpha. Exactly what is it? Well, that's something we're going to discuss a little bit later, probably in a separate video. For now, let's go back to the structure of hypotheses and let's discuss with some examples. Example number 1. Please stop the playback and read through. Alright, the drying time of a type of paint under specified test conditions is known to be normally distributed with a mean of 75 minutes and a standard deviation of 9 minutes. A group of chemists proposed a new additive designed to decrease the drying time, and in a lab test, the researchers obtained a mean drying time of 72.3 minutes in 25 observations. Set up appropriate hypothesis. What do you think? Is it going to be this, or this, or that? Well, one way to do this is to read the problem carefully. It says decrease the drying time, right? So the real mean mu or new mean mu has to go down, become smaller. Now, which is it? It's going to be the second one. Make sense? All right, now what is the null value? Status quo. We have two competing numbers. Which is it? Clearly, it's not 9 or 25. It should be 75 minutes or 72.3 minutes. Which is it? It's 75. Say 75 minutes. Because, number one, with a problem, this came from the study of these chemists after putting some new additive in there, right? So this is new value. Past value is 75. So previously it was 75, you see. Null is associated to status quo or past. Another way to look at is null means none, nothing, and this came from something. This came from sample. 72.3 minutes came from sample. It didn't come out of nowhere. 75 minutes, this one came out of nowhere. Not from the sample. That's a good way. Okay, all right. Null is mu is about 75, all right? Now, what is the alternative hypothesis? Structure is like this, either less or greater, and same number as before. Less than 75, greater than 75. How do you know it's less than 75? Well, 72.3 is less than 75. And also, with a problem, you want to decrease the drying time. So yeah, it has to go down. That's the structure. One of the more common mistake I see is something like this. This is wrong. You have to have the same mu0 value here. All right, same mu0 value here and also there. One is equality, or at least approximately equal. The other is greater or less. Significantly bigger, significantly less. Of course, if you just use equality and plain inequality notations, you're going to get full credit. Still, here I want it to be, a little bit more correct because I'm teaching here. I'm not a student. So make sure you follow the structure. Same mu0 here and there. And this is equality and inequality one way or the other. Now, sometimes you may have just different, but those are rare. Okay, how about the next example here? Oh, it's much longer. Please stop the playback and read through. All right. So what's the structure? Greater or less? Which is it? Or just different? Read the problem. These people want to improve the baby's health, right? And the baby's health at birth is measured by birth weight. And they want to increase the birth weight because lower birth weight means malnutrition. All right, so which is increase? This or that? Okay, that was easy. So they want to improve the baby's health, so they want to increase the baby's birth weight. All right, okay, we got the direction. Now, which number? we have a number of competing numbers here. 3,300 grams, 2,800 grams, 3,060 grams. Now, I don't think anybody will be puzzled at 500 grams here because it specifically says standard deviation. So that's not it. We are looking for the mean. So what is it? 3,300 grams, or 2,800 grams, or 3,060 grams? Okay, let's use process of elimination. Which one came from sample? You see, null hypothesis about past. It's about default. It didn't come from sample because sample study is something just took place. So the new value here, the mean of sample, is 3,060 grams. This one came from the random sample of 20 randomly selected babies. So 3060 is out. Okay, all right. Now, which is it? 3,300 or 2,800? It is 2,800 grams. 3,300 grams, by the way. Oh, excuse me. I just clicked the wrong key. Here, 3,300 grams doesn't do anything here in this problem. Maybe down the road, if this problem has multiple parts, later on it may be used somewhere, but not at this moment. 3,300 grams is all about the overall mean for entire United States. But here, these researchers are trying to improve the birth weight of babies born from women living in poverty. So we are talking about babies being born from a poor environment. So, the overall average, well, middle class or upper class, those mothers will take care of themselves and their babies. So they're fine. We're not going to spend additional resources there. As for women in poverty, we'll have to do something so that the babies are born in relatively better health. And among these, this is old result that did not come from sample, and this one is new result that did come from sample. And also, we want improvements, right? 3,060 is improved from 2,080, not from 3,300. All right, and also, the alternative hypothesis here, this one is not 3,060. We do not use sample mean here at all. Sample mean is something we use for testing, not setting up hypotheses. Remember, all these numbers here are mu zeros. 0 means null. It came out of nowhere. The third example here is about case number 3. I don't like this very much, but here it is anyway. In the previous problem, set of hypothesis based upon the question, is there sufficient evidence to declare the new parental care program made a difference? Here, difference means mathematical difference, blah, 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 blah. I don't know, and I cannot really think of any single example, any realistic example to apply this, because you see, in any case, sample mean is already there, 72.3. That was less than mu 0, so it's gotta be this. And here, 3,060 was already there. That is greater than 2,800 mean, so it's that. Why would we consider this as if we don't know anything at all, one way or the other? I don't know. So I'll skip the third one. All right, so much for the structure of hypotheses. We're going to talk about a little bit more theoretical detail, especially concerning the probability part in a separate video. Stay tuned.